All right, what's going on, Internet? So, if you follow AI conferences, AI gatherings, or kind of prominent AI startups, and you follow these either on YouTube or you're actually there in person, you'll see that a common conversation that happens or a themed conversation that happens is evals, so evaluating models. And it sounds not necessarily interesting, right? Well, some of the best founders of AI startups that are actually getting traction, funding, and also users, they tend to obsess over evals. They're not on X looking at really cool models that are being released or fancy features. Yeah, sure, they'll spend time there, but they're obsessing and focusing on evals. And that's the conversations they're having at summits at like Y Combinator and the AI Engineer Summit and other places like that. And you might be thinking, really? Evals? That's lame. Well, AI founders that have these prominent AI products, they know that understanding evals is critical. And the reason it's critical is if you can't see where the issues are, you're unable to actually provide a consistent product to your users on a reliable basis when you're using an AI model that's sometimes not deterministic but stochastic in nature. And the less jargony way to say that is you can actually determine what's going to happen instead of the model acting all crazy. So in today's video, I want to kind of uncover what these successful AI companies have realized and convey to you why evals are important and also how you can go about doing evals. All right. So before we get into anything, I want to give a huge shout out to Hamel. So Hamel has a YouTube video and also a blog where he actually goes through a lot of this content around evals. And there's also Jason Liu and others that I've kind of consolidated and distilled my ideas of how they actually do evals and talk about evals. And I'm going to try to convey that here with you in a simple way through slides, of course, as always. So we're going to start with this slide here at the very top. And here we have an axis of complexity. Now on one axis, we have a kind of a title that's, oh crap, we better evaluate this. So that's kind of the one axis. The other one is, oh, how fancy we're getting with AI. That's the other axis. Now, if we add some plots here, we can see this is kind of the journey that people go through when they're using AI or building with AI or building AI products. So first, we're vibing with GPT, and that feels good. We're getting clever with our system prompts. We're getting more sophisticated. And then maybe we're building some cool AI demos with different tools like Cursor and others. And then after we have our AI applications that are built, we're going to start demoing those and showing them off to some users, a small subset of users. And finally, we realize, okay, let's put this in production and scale it up and see what happens. Now, when you're going on this journey, people tend to have a lot of different thoughts. So first down here, you're like, oh, this is fun. I'm having a good time. Then we think, oh, okay, suddenly everybody starts caring about evals. They start really obsessing over this around this point and the progression. And at the end, things get real. And they're getting real because we realize that evals, the importance of evals increases as we start to get more and more fancy with our AI and also become more and more useful. So this is the journey that everybody kind of embarks on. And then this is kind of the importance behind evals and how it increases. And now you might ask yourself, so why? Why do evals matter? Well, this is the simplest way I can think about evals and why it's important. And it really comes down to how do you prioritize your time? And how do you effectively work on the things that are most important and the chain of things that your model does to ensure that you're getting the most out of it? And just like life and almost everything else, it comes down to the 80-20 principle. So in this example here, we have, say this is your AI, right? Your AI isn't necessarily just a responding AI, so you're not going to ask it a question and give you an answer. Likely, if you're going to have an AI inside of a product that's useful for users, it's going to have multiple steps. And people like to call this an agent. You can call it whatever you want, but it's basically an AI that has a multitude of steps. And in this situation, we have 10 steps. So you ask your AI here, so you have your user down here asking a question, and then it's going to iterate through all these different interactions and all these steps before it actually comes back in response to the user. Now, the issue here is that when you have a complex multi-step agent where it has all these different interactions, oftentimes if the responses start to degrade or you start to get errors, you're not necessarily sure where the error could be. It could be here, could be here, could be here, could be here, could be in any of these places. Now, the importance of evals is if we put in the infrastructure to actually evaluate the performance of a model, we can really focus our attention. We can focus 20% of our effort to get 80% of the result. And that's really the point of evals. And that's here. So say like in this case, if we had the infrastructure and we had the evaluator ability to look into our model and see how it's performing over time in our application, we would know that steps 2 and 7 are where most of the errors are occurring and exactly what types of errors are happening. So we know what to do to improve our model to actually get an 80% result or kickback or improvement based off of a small subset of our effort. And that's really the point of evals and the infrastructure associated to it. So now we got that out of the way. we move to the next step. So the next step here is actually, before we get into evals, I want to kind of put the brakes on and give you a bit of a warning here. And the warning is that it's important for us not to jump right into evals. We first want to start with unit tests. Now, if you've already written these, you can move on to evals, but oftentimes people don't. So the reason I'm putting this warning here is because you want to do this first. And the reason is because this is low-hanging fruit. And it's low-hanging fruit because in each one of these steps above, for our AI agent, these usually have very specific things that should occur. And unit tests can be broken into assumptions that we can write. And the really cool thing about unit tests, right? So unit tests are boring. People don't like to do them. Historically, people try to avoid unit tests. But we can actually have AI write unit tests for our AI. So it's AI all the way down. So you can use Cursor, you can use Windsurf or something like that, where it writes your specific test for the function. And you can even have the AI generate synthetic data that you run through the test. Let me show you an example down here. So say we have a RAG chatbot, right? And a RAG chatbot, you're supposed to ask it a question, it goes off to a database, it pulls the information back, and it gives it to our user. Well, there's a series of things that we can do with this chatbot to ensure that we have a series of unit tests to effectively check if it's doing what it should at a very kind of deterministic fashion. And like an example here is responses. So did it respond empty? If it gave an empty response, we should make it go back and have something that has something in the response and it's not empty. So that in itself is a unit test. We can kind of assert that this should be true, and if it's not, we should fix it before it gets to the user. The next one here is no response exceeds X length. So maybe you want to make sure your responses from your AI only are 2 sentences. I'm not sure why you'd want to do that, but maybe you would. And if that's the case, you can write a unit test to ensure that's the case. You don't necessarily have to work on evals yet. And this is the low-hanging fruit. So this is another 80-20 principle where we want to focus on putting these in place first for our overall AI application. Then we can move to evals. And remember, you can have AI write this stuff. You don't necessarily have to write it yourself. So it can write the tests for the functions you expect, and then it can create the synthetic data of a user asking a question. And then if it comes back in that way, you can kind of check that with unit test. Okay, so we've gone through unit tests. Now I want to do explain it like I'm 5. So I'm going to explain it like I'm 5 evals. So this is the simplest way I can convey this. Now, an eval is simply looking at your data. And it's looking at your data in a very specific way. So you insert ways to see how the application is kind of interacting over time. And then once you've done that, you want to do this thing called error analysis. And the way that Hamel likes to convey it, and the way I'll convey it here, is just looking at your data. So what does that actually mean? Well, your data, in a sense, is a conversation with your AI. So you're talking to the AI, you're getting responses back, or the AI is going off and doing actions. So what you want to do is you want to track that entire thing, and you want to say, okay, looking at maybe 50 iterations. So this is something that Hamel goes to, and I've seen Andrew something, the guy that kind of was famous for ML before ML was cool. It's usually between 50 and 100 examples you want to look at for your use cases, how your user interacts with your AI application. So when you're looking at this, you want to look at least those. And the reason they're putting these numbers out, because there's no static number or concrete number we should use, but we're just throwing something out there. And the reason we're throwing something out there is that this will get you started. And you'll understand what are the different types of ways my users can interact with my AI application. And then from that, I want to categorize and theme these in different categories. Once I've kind of categorized these, I can then say, okay, these are the different types of errors I can get in each side of category, in each one of these categories. And you can increase this over time. So you can look at 50, then 100, then 200, and you kind of go up that complexity curve until you have a good understanding of all the different types of errors you're seeing and the themes associated. And the reason we're going through that process of looking at this is going back to my point here, hopefully I don't make you sick, is making sure that we're looking at the things that actually matter. But we won't necessarily know this unless we look at all the data, not all of it, but some of the data, to understand what are the different categories of interactions we have, such as the multi-step action here. And then inside of these, what are the common error points that we have? And then from that, we can figure out, okay, this is where the biggest errors are happening, and this is what we need to fix. So that's what we're doing here, is we're basically looking at the data. And then here's, I have the point I just made previously. So you have different kinds of bad or different scenarios. So you have a scenario-based one where you basically can have an AI that has multi-match. So you ask it for a specific thing and it matches with multiple things in your database. So how do you handle that? Another one is maybe there's no match. So you have to be able to handle that well. Maybe your user actually gives a vague request and they ask for something that's not necessarily specific enough for the AI to know what to do with it. So the AI should know to ask back, what do they want? We have persona-based items. So maybe you have a new user, an expert user. Maybe it's a busy executive, or maybe it's an elderly person that doesn't necessarily know how to use technology as well as some of these alternatives. So we want to think about those personas. And the last one's features. So what are the features of my AI application? What can it do? It probably summarizes. Maybe it schedules stuff in your calendar, or maybe it searches something in your RAG database. These are just options, right? So this is not all inclusive. These are just kind of categories that you can expect to run into for some AI applications. So once we understand these categories and we've categorized them and understand the different types of errors we're running into, then we can move on to the next item here, which is tools. So I've actually done this here intentionally. So you can see we have different options. So we have, I think this is Langsmith. This is, I think, Brain Trust, Human in the Loop, or vice versa. So I think this is Human in the Loop, this is Brain Trust. And then we have Phoenix. These are one of many tools. So there's probably like 10 to 15 to 20 different options to track the types of conversations that are happening in your application. So the purpose of these tools is, simply put, is to track the information and to see how it's interacting. Now, often what happens is people get hung up on the tools. So as builders, we tend to get nerd sniped. We get obsessed with tools, we get obsessed with frameworks, which we'll talk about in a second. And when we get obsessed with these things, we kind of miss the forest through the trees. We're not focusing on why we're doing this. We're focused on the tool and the uniqueness and the features and all that stuff associated to it. And the reason I put this here is that Google Sheets or Excel can help us solve this problem in the sense that maybe we skip over the tools to start with, or maybe we just use a simple tool such as Phoenix to get the data. Once we've gotten the data from Phoenix, we can then export that into a CSV and put that into Google Sheets and just simply look through each one of the conversations to see what are some of the common errors. And this is a way to avoid getting nerd sniped. We don't want to get nerd sniped with all these tools. So we've done that. And then an example here I want to share. So say if we're using Phoenix, which has an open source option, and the way you integrate these different types of tools, which they're all slightly different, but they're all kind of the same, in the sense that say you have your code. So this is what our code is here. And in our code, we have our imports, we have our init statements, and we have different types of functions in our code. So what's going to happen with Phoenix and other things is we're going to insert different tracers. So you're going to insert a tracer at the top of each one of these functions, and then you're going to have an init piece here that you're going to kind of initialize the tracer itself. So this is the kind of the basic flow of how this is going to interact with your code. Once you've done this, then it's going to kind of pull this data out. It's going to pull both the input and the output from each one of those functions when users interact with that specific LLM or the actions associated to the LLM over time. That's just a simplistic understanding of how this kind of gets inserted. And then once this is inserted, you can use the UI that comes with Phoenix. But one other thing that I've seen Hamel talk quite a lot about is using a custom dashboard such as Shiny for Python. And the reason he actually pushes for this is that these different dashboards that come with these tools, like out of the box, they tend to be templated. And most LLM applications or AI applications, they have very custom use cases, and it's important to actually modify your dashboard to make it as easy as possible for you to look at the data. Because that's the end goal here, remember, is we're not trying to get distracted by the tools, we're trying to reduce the friction as much as possible. And one of the ways of doing that is creating a dashboard specific for that use case, where you can easily flip through the conversations and even tag them as good, bad, and then critique them over time. So that's one of the reasons that he recommends using this and kind of building it out. And the way that would interact, actually, to kind of give you a quick summary, is you would use Phoenix to pull the information out. So this would be basically pulling the data out of the application. And once you've pulled the data out of the application, then you would push it towards the dashboard for Shiny. And then in this dashboard, you can modify it and show different types of things you're interested in. So you would basically export to CSV and put it into this dashboard. So once we've gotten to the tools, we go to frameworks. Now in frameworks, oftentimes you'll see that there are different ways to evaluate models. And oftentimes these frameworks that people get, this is another thing you can get, actually, another nerd sniped opportunity is to get obsessed with frameworks and thinking about all the different ways we can evaluate our model and all the different complexities of measuring the type of goodness for each response, etc. And there's a huge issue here. where most of the frameworks that people talk about and look at that are kind of templated and out of the box, they tend to be on a spectrum. So it's 1 through 5, A through F, whatever else. And you can see that there's a kind of a different categories of helpfulness, tone, accuracy, etc. The issue with this is that this is mostly subjective. And how do we know if, a 3 of helpfulness and like what's the difference between a 5 and a 3 of helpfulness? Or a 5 and a 4 of accuracy? It's really hard to determine and measure and quantify the difference between these different categories as you kind of go from band to band. That's the reason that we try to avoid this as much as possible. And instead of using a spectrum of evaluations, we actually want to use something that's binary. So we want it to be 1 or 0, yes or no, check or no check. And an example here is, say we're doing a RAG application again. So we have a RAG application for our AI. And a few different examples here is one, is the answer that came out of the AI factually correct? So if I look at the answer from the AI and I look at the documents in the database, did it answer it accurately? Is this correct? Yes, no. Another one, is the answer relevant to the question? So if I ask a question to the AI about bananas and it comes back with an answer of options trading, I know that those are not relevant. So if that's the case, I know that this is not relevant. So that's going to be a no. And we try to basically boil our evals down to something that's binary. And most questions you can do this. You just have to take time to think it through. So remember, when you're doing frameworks, focus on binary, not spectrum, and try to boil all your questions down to something that's yes or no, or on or off kind of thing. And one quick reason as to why this is relevant is when you do this, it allows you to actually ensure that each one of the steps you can improve kind of definitively. You know if it's gotten better or not based off the binary option you've given it. And also, this gives you the ability to have critiques that will then kind of shove into this next point, which is having an LLM judge on our behalf. Okay. And then last one here is LLM as a judge. So I'm not going to spend a bunch of time here because this is going to be continued. I'll make a future video, probably the next one, all about this topic because there's a lot involved in it. But before I get into that, I just wanted to kind of give you a quick overview of what this type of process looks like. So for LLM as judges, the first step is you want to get an expert. You want to get somebody that specializes in this specific area. So it could be a lawyer, it could be an accountant, it could be a customer support director, somebody like that. Once you've gotten your expert, you want to then generate data. And you're going to generate data either probably from both users and AI. So if you have users already using your AI application, you can take a sampling from that and say, okay, this is the type of conversations that are being had. So let's add that to our database. And then also we're going to have AI create synthetic data for each one of the scenarios that we defined above. Remember, we have personas, we have features, and we have scenarios. I think those were the ones. Features, personas, and scenarios, yeah. And then there's a bunch of different categories as well. Those are just 3 of many. And so we're going to have it generate data associated to those scenarios of what we think we could face. Once we've done that, then we'll have our expert judge the LLM's responses. So we're going to have it go through the process of answering these questions in those scenarios to see what happens. And as we do that, the expert's going to go through and judge, okay, was it good? Was it bad? Was it accurate? Was it not? Was it relevant? Was it not? Things like that. And they're going to have all this put into it could be a Google Sheet or something else. It could be a fancy dashboard, but it's usually recommended to start with something simple such as Excel or Google Sheets to put that in a place that easily is maneuverable for the expert, because oftentimes your expert's not going to be a developer. They're not going to know how to use these tools. So we want to make it as simple as possible to remove any friction so they actually get involved. Once we've done that and we've gotten all of our scores back, we're then going to do some error analysis. And the error analysis is basically looking at the data. Remember, this is a fancy way of saying looking at data. And you're going to basically look at this Google Sheet that you've created previously, and you're going to go through each one of those rows and say, okay, where were we wrong and why was it wrong? Because when the expert judges this, it's not going to say yes, no only. It's also going to critique the responses. So it's going to say it was wrong for this reason. It was right for this reason. It was wrong for this reason. And they're going to give critiques and you're going to read through that. And once you've read through that, you'll start to see, okay, these are the themes of categories that we're starting to see. We can see, okay, we have theme A, theme B, theme C, theme D. We can see from these themes that maybe theme B has the most errors that we're getting, and there's a specific reason that we're getting errors in that theme. So that then gives us the ability to iteratively improve on our LLM as a judge. So we're going to iterate both on this and this. So this probably should be swapped, but we'll probably build our LLM as a judge first. So once we built it based off of our understanding of what the expert judge is, then we'll iterate on that over here. So we'll start to iterate on that LLM as a judge, that system prompt that we baked into the LLM that's judging this over time. And I probably should take a step back. So what is an LLM as a judge? This, simply put, is an AI that's judging another AI. So your AI's output is being evaluated in an automated fashion by another LLM that's trained specifically to do that task. And we're going to iterate on that judge over time to improve its ability to make more sophisticated and accurate judgments of the output from our AI application. All right. With that being said, Internet, I hope you found this useful. Hope you found this entertaining. If you did, please like, subscribe, share with your friends. And if you need assistance with internal processes being automated with AI, please reach out. I have a company called Gradient Labs that we do exactly that. So if you're interested, link in the description, we can book a free 15-minute call to see if there's a good fit. With that being said, Internet, I will see you next time.